Hey everybody, it's Nick for today's tutorial. We're going to look at doing some digital fabrication, and we're going to be using computation to panelize our surface and then distribute those parts to a cut sheet. And as you can see, they're actually labeled, so you can see each piece has a number. And then if you go to the cut sheet, there's a number and a part. And if you recognize the Iowa State laser cut template, these are for being cut, and then there's a layer for things that are scored. And so that would allow you to actually fabricate something like this. And I've talked about this a lot in class. Like there's all kinds of folks that work in computation that help architects build things. It's one thing to be able to draw it in the computer and to make sections of it and plans and renderings and that kind of thing, but you've actually got to build these things. And that's where looking at different kinds of geometry, being able to change it from something that's curved to something flat, or to understand the structure of it, and then also to try to organize things, come in handy. And so this is where we're going to end up today. And but it's not the end of the project. As you're going to see, there's a few things missing in this that we have to cover, and I'm also going to go back and explain some of the concepts that we've seen from this video. But I thought I'd go ahead and start with this just to give you a sense of like how far you can get with just a few simple changes to our old script. So, and that's actually where we're going to start. We're actually going to go ahead and open up Grasshopper and get your service demo final script. So that's the one that I created, from the very first part of the assignment. That's already done. It already has kind of a base surface in it. It already has the panels and everything, and like the color, like with the attractor, and that sort of stuff. So go ahead and start with that. Um, we're going to be making a model of this, and as I talked about in class, I think it should probably be no more than 18 inches square, just because the amount of material it's going to take, as you'll see, is going to be a few 18 by 24 sheets, and we want to try to minimize that. So I think if we start with something that's 18 by 18, we'll probably get close to one sheet, if not part of another sheet. And so that's a good way to just to start. And I don't really care in terms of this, in terms of the actual scale. We're not going to build this. We're not going to present it to a client. But I do want you to think about the scale of the model. Um, so regardless of how large, this was when you actually made it in Rhino, you're going to need to get it down to the actual scale that you're going to fabricate it. Okay. And to do that, what we're going to do is go ahead and change your units to inches. So just go into model units, inches. And you could say, well, I could do all this stuff and then I could shrink it down later, like to the size I want. Well, actually, no, because in the next part of the video, we're going to be looking at fasteners, and we need this to be the actual dimensions now, so that when we're doing sliders and things in here, Grasshopper units are kind of unitless, well, especially UVs, like these things. This is actually based on whatever the units are here. So previously, these were feet, which is enormous. And now that we've changed the scale of the file to inches, we're actually going to these are going to be inches. Um, if the file asks you to change the scale and that says multiply by 12, just say no. We don't really care about that right now. So your file should be mostly empty. You might have those pedestals in there or those points, but yeah. So just go ahead and get that thing shrunk down. And then what we're going to do just to get a sense of things is make a little 18 by 18 rectangle just for scale purposes. So I'm going to make a rectangle and go to the center for the type. And the center is going to be good old 0, 0. And then the length is going to be 18 inches. And we're going to use the same for the end. So we're just going to press enter, and that gives us an 18 by 18 inch. And you can see like our pavilion is quite a bit bigger than an 18-inch thing. So what I'm going to do, just to kind of minimize things a little bit here, is I'm going to go ahead and make a scale component. And we're going to take the surface. And the nice thing about this is the center is already 0, 0, because that's what we did. So no big deal. And I'm going to take a number slider, and we're just going to eyeball this, folks. So what I'm going to do is, you can see that that's 18 inches. So I'm just going to keep shrinking it until it gets to the size I can manage. And that's it. That's what I'm going to do. okay? And that is going to be my new surface. And for clarity, I can just probably pop this into a surface component. And then if you wanted to, you could plug this into all these other guys, but we're not going to mess with that right now. Okay, we're going to go all the way back to the end here for now and turn this off. Actually, I can probably turn it on. Because what we're going to do is we're going to take that new surface and we were going to be fabricating this. And remember, things that we build in architecture are often flat, or it's easier to build them flat, at least for now. And so we think about planes. And a plane is defined by 3 points. Like any 3 points in space will define a plane. A lot of these objects that we have that come out squares are actually not planes. They are 2 triangles. And if we build our surface using squares, either there's going to be a little bit of twisting if we're going to cut that square out and it may not line up with the other piece, or we'd have to score it or something so that we get the 2 triangles, and that's just a ton of work. So for now, I would really recommend focusing on the following 3 types here. So I'm going to go ahead and plug this in for this and plug it in here. And now this is what we're talking about. I'm going to go ahead and hide these. And these triangles you can fabricate. It's not that big of a deal. And if you plug this one in, oops, you just get a lot more triangles. What did I break? Oh, because I didn't plug in the surface. Aha. Nick, there we go. There you go. You'll get a lot more. Now, if you want, I mean, don't do that. What you want to do is go ahead and turn your U and V divisions way down. I would say, depending on the style you're going to fabricate, you might go down to, 7 and 7. That's 49 panels, and in this case, if you use this type, it's holy cow, 196. So I would think really carefully about that. I'm going to go ahead and go back to this type and go back to here. And now I've got something, okay, 56. I'm going to do that because there's actually one more in the U than showing up here. Okay, so I can handle that, especially with a partner. These computational things, when you're doing fabrication, they make a ton of pieces. And it's something you've got to watch out for. The reason why Mark Ferns' office or firm is called The Very Many is because his projects are made up of a lot of pieces. That's one thing a computation does is it just makes this kind of stuff so easy that you can kind of, make so many parts that it just gets kind of out of control. So anyway, careful with that. You can do what you want. If you and your partners think you can manage it, you can go right ahead and have a lot of panels. One thing I will say though is, the fewer panels you have, right, the less curvature you're going to represent. So that's something to watch out for too. I mean, it's not just a matter of making it easy. I mean, you are changing the form, you are changing what it represents, and that's something to kind of watch out for. Okay, so we've got that, and we have got our, let's see, we've got this going. So what we're going to do is we're going to start by making our cut sheet. And actually, before I get too far, I'm going to go ahead and hide all these points that keep floating around. Okay, we're going to go ahead and make a cut sheet. To do that, I'm just making another rectangle, drop a point, and I believe the size of the sheets you guys have, you guys can verify this, I think it's 24 by 18. So we're just going to make a 24 by 18 rectangle. Okay, and I'm going to assume that that's it. What we're going to do, though, is we're going to lay these parts out on the sheet. And in order to do that, we get back to this idea of planes again. There's this. You might say, well, I could just take these things and separate them, and I could do a couple of different sort of if I rotated it, or I sort of like took it and projected it onto the surface, I could get those parts on there. But actually, there's multiple rotations in order to get these things flat. And a lot of times, if you don't do it right, you'll end up distorting them. And then when you actually try to fabricate it, it won't work. And so the easiest thing to do is actually to take each of these planes and then transfer that plane to a flat plane, like basically reorient that using transformations. And in fact, in Rhino, or in Grasshopper, this is pretty easy to do. We're going to use the old Orient component. And this thing is great. It also works well to distribute geometry. We'll show you that later. Those takes in geometry as an input, and then the base plane of where the geometry came from, and then where you want that to go. Okay, we're going to go backwards here. So we're going to start laying things out on the sheet. And to do that, I'm going to go ahead and take that curve, that rectangle of the sheet, set that curve. And this is going to be a lot easier if I can work with it as a surface. So I'm going to go ahead and make it a boundary surface. And this is one instance of taking a curve and converting it to a surface. If you have a flat, closed curve, you will get a boundary surface. And I think that makes sense. I'm going to go ahead and hide that so I can work with it. I'm going to go ahead and hide this too for now. There we go. All right. So we got these things. Oh, and this is left over from the, I'll find it later. Okay. Oh, from the Orient component. Okay. Surface. Now I'm going to use a pattern that I use a lot, and I want you guys to really like memorize this. This is how you divide up a surface. And it works on any surface. We're going to use an isotrim, plug in the surface, and then we're going to do a divide domain squared. And then we're going to go and plug that in and plug it in here. Now, I can do all kinds of things for the U and the V with this. To make things easier for me, I'm going to make it parametric, but you don't have to. You need to have as many spots on the paper as you have pieces, or more. Okay. And if yours doesn't quite work, that's okay, because again, we're actually going to have some problems at the end of the day that we're going to solve with some later videos. But go ahead and plug in U and go ahead and plug in V. Now remember, I have 56 pieces. I'm going to go ahead and make a little panel here. And in fact, I'm going to do something else that's going to come in handy later. If you ever want to know how many of something there are, or if you need to use that to do something, a really easy thing to do is to do what's called a list length component. List length. And that would give you the length of a list. And so now we say, I have 56 things. And that's just kind of there so I can see it. So when I check this, am I going to have, I have 49. So I'm going to do what I said and go ahead and just add an x plus 1 to make that the same domain. Because again, in the way that this component works, it actually adds an extra u. And you would never know that. But basically, it's really nice when things agree. And if you have to have a little math to do that, that's how you do it. So we end up with 56 panels. I'm going to go ahead and hide all this stuff. Well, not this. And then, okay. Then another handy thing that we do a lot is we find the center of things. And then to do that, we just use like an area component. This is a pattern we use over and over again. We used it when we shrunk the cells on the canopy in order to create the openings. So we're going to go ahead and take that centroid, and we need a plane to put all of our pieces in. We need each one to have a plane. So what we're going to do is we're going to drop an XY plane. An XY plane is basically what you're used to working in Rhino. It's as if there's a floor. You can see the X goes this way and the Y goes that way. So we're going to make a lot of XY planes. And planes are important because it's where we build things. And I'll talk about that later, but that's why we bother with it at all. So it's kind of like the site. I'm going to make a bunch of planes, 56 planes, and I'm going to pipe them into the geometry component. In fact, I'm going to go ahead and turn that curve back on so you have a boundary, and then turn these off. There we go. Now you're not going to see anything yet. That's okay. Okay. The next part is we have to find the planes of all of these pieces, because each one has a different plane. And to do that, we're going to use another pattern, and we'll talk about this in a future video, but this is another pattern that's really helpful to know. So I'm going to go ahead and move all this stuff over a little bit while I work. And I'm going to take this surface, and I'm going to go ahead, again, and make an area component. And what I want to do is I want to find at this point what the plane of the surface is. And you can do that with a component called evaluate surface, and it takes a surface and it takes a UV point, and the UV point is the coordinate system of each of these planes of that surface. It's a special coordinate system, and the reason why that, and I'll show you this later, but it makes it easier to work, so you don't have to worry about what the actual world coordinates are. You worry about the coordinates with respect to that plane. So how do you find the UV coordinate? Well, what you can do is there's a component called closest point, if I can spell it right. Surface closest point. and I'm going to take the centroid, and it's going to go for points, and the surface is going to go for S. And you get the UV coordinates. You can see these are very small. They're like basically like a domain of 1.5 to 1.5 or 2 or whatever. That's because that's only as big as these things are. They're only like an inch or two big. I'm gonna go ahead and pipe that in, and of course the surface you've got is here. You can see all these crazy, and what you get are the frames. So the frames are what you want. We call the local coordinate system a frame. I'm gonna go and hide all this. I'm gonna go ahead and pipe this over here. Well, I'll do it on top because we're gonna take the F and we're gonna plug it into the A component. There you go. So nothing happened. Well, that's because we didn't put any pieces into it. So let's go back to the surfaces and let's plug it in for G. There we go. All the pieces are on the sheet. And real quick, let's go ahead and get the pieces out. So these are surfaces, and surfaces are nice to work with, but they're not stuff we can laser cut yet. We need to get the vectors from the edges. So to do that, I'm going to go ahead and do a brep explode, which is called Deconstruct brep also, but used to be called brep explode. Both of them work. It's a really valuable component because it's how we get faces and edges and vertices of any surface or any kind of brep. We got the edges. We're going to do join curves. Plug them in. We're going to go ahead and flatten. Hide this stuff. Curves. Now you say, oh, Nick, this is all jumbly and bad and like, I don't like it. So yeah. So we have a problem here. We don't have enough room on our sheet. We also have a lot of wasted material. So that's kind of a bummer. So just for now, just to move things along here, let's go ahead and make a really big sheet of paper. And let's pretend that we don't actually care about how much the laser cutter can cut. We're just going to go ahead and make a new one and go ahead and set that for the new curve. Now we've got some breathing room to kind of see what we've got, see all these pieces and things. And again, I mean, that's the beauty of having this thing be parametric, right? I'm going to go ahead and turn these frames off. Oh, they're in the way. Is that I could just change that sheet really easily, right? And I mean, hey, folks, if I increase the number of pieces, there you go. It's pretty cool. But let's take a step back for now. Now would be a good time to save your file if you are not in the habit of doing so. I would also save copies as you go. Okay, so I've got this stuff. I'm going to go ahead and hide this now. So always kind of keep your stuff tidy as you go. So I got these curves, and that's going to be the stuff that I bake, and I'm going to export that and laser cut that. And that's pretty cool. But we're missing a couple of things. First of all, we don't have these interior things, right? So a real quick way to get those is go ahead and copy the Orient. And remember, these are the interiors. So I'm just going to go ahead and pipe that in for the geometry. Actually, I should have just copied these two. There we go. Boop. There you are. Easy peasy. So we got the inside and the outside. And now you can really tell that these are all different. Before you might not have believed me, but you can see that some of these have very small openings, some of them have very large openings. And that's because of that attractor. You can see that they get lighter as they go up. And it's actually a pretty smart strategy for this thing if you're really going to build it, because you want there to be more material here and less material as you go, so it gets lighter, and also maybe because you want to bring in some daylight. So that's not too bad. That's sort of intelligent, right? So we've got our cut sheet. Okay, so we're still missing a couple things. We got to figure out how we're going to actually build this thing. And I don't know about you, but like I don't exactly know which piece is which. I mean, I could probably put the colors of them on there, but that's not really going to do me any favors either. So we got to think about that. What we got to do is we got to add numbers to these things. All right, you've actually got to know, have a system for fabricating. And to do that, I'm gonna have to have you guys install two plugins. So they're on the webpage. There's one called like there's one that's supposed to be sort of like elephant, but it's elephant. I think that's the joke. And it's a tool that it has a lot of different sort of like annotation tools and visualization tools, and we'll look at it later. And then Fab Tools, which is really handy. It packages a lot of different fabrication utilities. So I'm gonna have you guys get those. There's also a set of examples that could teach you how to use some of the Fab Tools components. But go ahead at this point, in Rhino, go ahead and go to Special Folders, Components folder, and then go ahead and drag those components into this folder. You can see I've already put in Elephant. I've already put in I don't know, Fab Tools are probably in there somewhere. So anyway, go ahead and get those in there. And all of that stuff should work pretty well. Let me make sure. Yeah, both of those should be in there. Okay. So once you've got that, you're going to get this up here, this Elephant. And I want to say, I can't remember where the Fab Tools are in there. Let me make sure. Yeah, this is the one we want. So that's in there somewhere. Okay. We'll figure it out. Let's go back here. Let me get this going. Okay. So what we're going to do is make some dots. And a dot is a special Rhino object. It's in Rhino, actually. So dot. And you can say like, I'm just going to use the word dot 1. And you can just put a dot in something, and it'll always stay in front of the camera, in front of the Rhino camera, and it doesn't really change size. So they're really quite handy, and they're great for labeling or making notes to people. If you want to make a note for somebody in a file and give it to them, you can say, hey, fix this thing, or look at what I did. Dot's a great tool. But Grasshopper doesn't make dots. So you've got to use Elephant because it contains a dot tool. And under the annotation elements. And that's what I really like about this, because you'll find these are incredibly handy. There are other ways to put text on things in Grasshopper, but this is the best way. As for its function in digital fabrication, it's just easier. So okay, to do this, we're going to go ahead and drop the old dot component here, and the dot wants text, fine, and it wants a location, yes, and we don't have to worry about the size. We probably do. I'll worry about that later too. So let's go ahead and make some dots. I'm going to go and clean this out here. Get out of my way. Okay. Alrighty, and this is where this comes in handy. So we need a list of numbers. So we're going to make a series. And the series is going to be from 0, and we're not going to do that. We're going to make it 1, 2, 56. And if you really wanted to, it's probably, yeah, we'll see if that works. I might need to take 1 out, but because it's 56 elements. 1 to 56. We'll see. It might need to be 1 to 55. Well, that's an easy fix. Okay, so that goes in for the text. And the location, well, I'm going to keep making components for I could be reusing these, but I'm not going to. So I'm going to go ahead and plug it in. You got the center of all these things. And we've got dots. There you go. And now, how cool is that? No matter where you are, you can look at this thing. You can say, that's piece number 8. Piece number 50. Actually, you do it 56. All right. I overthought it. And the big one's 28 on top. Cool. All right. So we got some dots. Now we can figure out where things are. Let's go ahead and label our parts correspondingly. All right. To do that, though, you have to find a place to put the label. And you can't put the label... I need to put the label on the piece, because if I put it in the center, I'm cutting that out. I'm going to lose that. I'm not going to be able to find it, and that's not good. So I need to find a place. What I'm going to do is I'm probably going to take, and I'm lucky because these are triangles. If it was another shape, I'd have to figure out something a little sneakier. But the method I'm going to show you will work in a lot of cases. So real quick, what I'm going to do is I'm going to go back, and remember, I've still got these things on the pages, and they are surfaces until I turn them into curves. So I can go back to my trusty area component. Let's get this out of the way here. And then what I'm going to do is I'm going to go ahead, same thing here. Oops, don't delete that. Take my component here, plug it in. Oops, did that again. Plug in this thing. Yeah, now I've got these back again. I'll get rid of that area component. No, wait, I want that. Sorry. Um, okay. And I can unflatten this. And what I want are the vertices. And specifically what I want is the vertex that's on this corner here. And so what I'm going to do is I'm going to do a list item. Inside all these data structures, there are lists. We know this, right? If I look at a panel, it's there are 56 groups. You can see down at the bottom there, it says 0, 0, 55, n equals 3 at the very bottom of that list. So there's 55, well, sorry, there's 56 objects, and they count from 0 to 55. And inside of those, there are 3 points, right? So for each of those surfaces, there's 3 points. So they have like an address. This is the first one, it's 0, 1, and then inside of it is a list of points 0, 1, 2. Okay, that's what we're going to get into. We're going to get point 0. Unfortunately, that's really easy. All I do is plug this into the list item, and now I've got that point. It's because the index of that is 0. And just to kind of show you what the difference, so if I plug this in, 0 is here, 1, 2, and you can't, it'll keep going because it wraps around, but you get the idea. So that's how you access data. If you want to specifically talk to some object within a list, you use a list item. And since these are all grouped together, if we ask for index 0, we get 56 points. And I'm going to go ahead and flatten these because I don't want them structured anymore. I just want them to be points so that they can talk to these centers. And what am I going to do? I'm going to pull this point in so I can put text on it. And I'm going to pull it towards the center of this thing. And to do that, I'm going to make a vector. And you guys know vectors from math, and we talked about them in class, but just to kind of illustrate what a vector is, basically just a line between, 2 points. So this is a vector. And if I give that a magnitude, I can say how far along I want to move it towards that point. And this is actually how offset works. Like when you're offsetting something, it's actually drawing a vector from like a center point, and it's pulling the point in towards it, which is actually kind of cool. So anyway, I'm going to go ahead and do that. And to do that, I'm going to build a vector. And so I'm going to use vector 2point, which says take a vector. And in this case, I'm going to start from here and move to there, because that direction is important. You don't actually see the vector. And then I'm going to use move. And if you've ever looked at move, we often use move to move things up. We always plug in like a unit z. Well, that's a vector. They're both vectors, right? And you can plug in anything. You can plug in, the x, or you can plug in the y. You can also plug in your own like vector that you created. But that vector doesn't really have any intelligence. We don't know how far to move something, right? That's why we always have to have a number slider when we put our z vector in. So I'm going to go ahead and put in a slider. And let's see here. I'll probably make it point. Oh man, 0.125 to 1 to 1 point. No, to like 3. That just gives us a good range of units and decimals to work with. We're only going to be moving it probably a 16th of an inch, but I just want to have the flexibility. That's what's nice about parametrics. I don't have to decide right now. Okay, so the geometry. The geometry is going to be the point we're going to move. The vector goes into the multiplier. The number slider goes into the multiplier. The vector goes into the transform. Oh, I moved it really far. Yeah, I did it backwards. Thinking too hard. Okay, let's go back this way. Now we're going to be moving. Oh, and it moves out from there. So I'm going to go ahead and add a negative modifier to it. So, oops, don't do that. There we go. Oh, I guess I'll have to do this here. So I'm going to go into expression, and it goes off my screen. So I'll just fix this. Go negative x. There, make it negative. Gee whiz. Still not doing what I wanted it to do exactly. Let's see here. Hang on, folks. Okay. Let's see here. Maybe if I no. Okay. Well, let's just. Yeah. Okay. Jeez. So that works. That's what we're doing. There we go. All right, so move it in, and okay, it ends up being so no. And I did this because if I ever wanted to actually measure something, like if I knew what the tolerance of this material was, or I knew where the overlaps were going to be, I could look at this and say, okay, that's going to be a quarter of an inch, or that's going to be an eighth of an inch. So that's useful. Okay, now I got all this stuff. I'm gonna go ahead and pipe this back a little bit. And as you work, if you've got stuff, you can go ahead and group them. Just do Control G. And then you can actually give it a title. So you can say outer uh, cut. Go here and say like, and this is actually the sheet. So material sheet. And these are the interior cut. You can call them what you want, but this lets you just move them around too. Like you just click that surface then, or sorry, that group, and just move it around, and that's kind of nice. And this is these are gonna be model dots. You can change the color of them and stuff. Don't have to be purple. Okay. Now I'm gonna go into my text, and this is the text from Fab Tools. Is not the other ones here. So we're going to do text, and this one's real easy. We're going to go in for the location L. The text is going to be the same as we had here. Very important. And it's pretty big, so just drop a regular number slider here. Ooh, and that's actually great. So a quarter of an inch seems pretty good. All right, go ahead and hide these. And, if you wanted to move them or whatever, you could move them closer, make them smaller, whatever, as long as you can. And this is also something I like about the Fab Tools thing, is that it makes these fonts, they don't have any curves. Might sound really funny, but curves actually take longer to laser cut. You probably figured that out. Linear cuts are easier, so they made this linear font for the numbering. And for the text, that's really easy. And then they also had these hash marks on them so that you can tell which side is which. So yeah, that's it. So that's why I use that instead of like Arial or Helvetica or something like that. It's very like utilitarian. Let's see here. I'm gonna go ahead and group these folks, and that is the label text and cut sheet numbering. Fair enough. Okay, so that's pretty cool. So now we can cut these things out, and we know where they go. And it's a really good idea to verify your stuff to make sure. So like, let's look at part number 8. Let's make sure. Let's find you, number 8. Oh, you're in the corner there. Aha. Yeah, that's a small hole. Good. And 28 is the one that's got the big opening, right? It looks like. Yep, 28. Cool. All right. Let's see here. So yeah, so what we can do is, well, I'll say something too. You can see how that overlaps and that would bother you, and you might have to go and fix it. Look, like when you bake these things or whatever, it's real easy once you're done. Just go through and move the ones over that are in the wrong spot, or just make changes. Remember, modify exceptions last, right? Like if there's only a couple that you have to change, there's no sense in like coding a bunch of stuff just to fix a problem that one or two of them have. You can always bake this stuff and then just edit the curve. It's not that big of a deal. You definitely want a solution that works for most cases, and that's pretty much what we've got. Like I'm fairly satisfied with that. So now it's time to start baking things. And to do that, I'm going to go ahead and make some groups just to make things easier. So we're going to make a group, and we're going to plug this in and hold shift and plug that in. And that's going to be our cut group. And so you can just bake that. And I would make layers, with the colors and stuff. I didn't do that ahead of time, but I'm just going to go ahead and bake it. So you say yes. Now it's actually baked. It's pretty cool. And just for the sake of clarity, go ahead and make a score group here. And oh, flatten these. Yeah, bake them and go to layer 2. Kaboom. And go and hide these. And just to prove what we've got here, look at that. So these are, well, they're purple, but they would be blue, right, for scoring, or I think that's what the template uses. And then red for cutting. And you bake that stuff like we did, and you've got curves. And I assume you can get curves out of Rhino and get them into the laser, right? Put them into Illustrator. No big deal. Just make sure the scale's right. So there we are. We ended up pretty much where I said we would. We've got a laser cut setup. We've got a model so we can tell like where the pieces are. That's pretty cool. The whole thing's parametric. So if we make any changes or we want to make more of them, we can. So that's like really cool. This demonstrates, some of these big ideas about like computation. We've got these tools. Like we built a system to take these panels and put them on a sheet, and we have a dot system. We have a labeling system. You put any surface in, and you could run it through this whole thing and like fabricate it. I'm not saying it will always work or whatever, but at least you've got a basis for it. These are patterns that you can reuse. You don't have to rebuild them all the time. You can say, okay, this is how I make a sheet. This is how I, make dots for something like that. You can just copy paste those from other code, and they're like tools that you've already got made, right? But this is pretty flexible. This is a pretty good system, right? But it's not fabrication. Like think about it. How are these things like attached to each other, right? If I gave you this would be a nightmare. I don't know. You probably have to have tape or something. How do you make sure you get the right angles between things? Like you could do it. Like if I made you, you could probably do it with hot glue or crazy glue or something like that. But it would be a nightmare. No, you'd really want fasteners. You'd want tabs or some kind of strips between them or something like that. And so that's actually something that we have to talk about in the next set of videos. Is how do we get like fasteners for things, right? The other thing I think about is does this thing stand up? You can certainly build it, but is it like a good idea? So we might want to look at like are there places where we need more material or we need bracing? Is that actually a true vault? We're probably in good shape because we started with catenaries, but the catenaries we did were arbitrary. We just kind of plugged in numbers until we got something we wanted. So we need to be thinking about putting some intelligence in this so that we can understand actually how this thing might stand up and make some changes. But that's okay. I mean, we had this beautiful thing where, if we change the surface again, it's going to get piped through like all this stuff. And yeah, so we're not in trouble. That's not going to be too bad. Yeah. So this is just a real demonstration though of how to take a model and translate this representation into another representation, right? Into construction documents. The last thing is like I said, this is a big sheet of material. Look at all the wasted material that's in this thing, right? There's got to be a way, and there is, to sort these things out to get them to fit, tighter on a sheet. If we rotated some of them, flipped them, just packed them in tighter, could we get this thing on a sheet of 18 by 24? Like, is that possible? Or at least fewer sheets. But this is super wasteful. It's too big for the laser. It's not actually going to work. I mean, at this point, if you had to, you could go ahead and Rhino, and these are all grouped together, but you could ungroup these, right? And you could, take them, and these are grouped too, ungroup. You could take them and move them around yourself and all that if you wanted to, right? But once again, I'm going to give you a script, or we're going to build a script together that's going to actually pack these in better. It's actually a process called nesting. So we're going to talk about how to nest things. All right, that's a good place to stop for today. But at least it gives you a sense, though, that like this is real. This can save us a lot of time. We got pretty far, and we got a lot of ideas. We talked about numbers to points, points to curves. Today we talked a lot about curves to surfaces, and how to get information, out of a surface, like how to get the faces, the edges, the points So yeah, so we're gonna go back and review that stuff now that we've seen an example of it. And yeah, all right. So anyway, let us know if you have any questions, but I'll see you guys again for next class.